Good morning, everyone. Let's wait 2 minutes till everyone has joined the webinar, and then we will start. Good morning, everyone. I'm Daniela Roth, the Marketing Manager for DACH and UK at Mega International, and I'm delighted to welcome you to today's webinar, Collaborating with AI, Empowering the A-Team. This is a joint Mega International and T2B webinar, so let me briefly remind you who we are. Mega International is a global SaaS software company headquartered in Paris with offices in 10 countries. We create leading software solutions and handle more than 2,000 customers in 52 countries around the world from many industries. We are a team of 350 multicultural, passionate, and dynamic professionals who create, sell, and also implement software for the largest companies. At Mega, we're working on developing the next generation of EA, fully powered by AI. This means transforming EA into an intelligent co-pilot that can assist users using natural language and AI-based recommendations. Our aim at Mega is to maximize the value that EA delivers. We want to boost performance, efficiency, and accuracy to create a more agile, innovative, and secure environment for businesses. This is all about making enterprise architecture work smarter and more effectively for you. With us for you today is our esteemed partner in Swiss operations, T2B. They are successfully supporting Swiss companies and the government since 2001. T2B is based in Basel and Bern and counts 25 senior architects, engineers, and business analysts who are supporting medium and large enterprises, as well as government units in different areas. For example, integration architecture and API management, also data architecture and governance, data science, machine learning, and AI. That's why we're here today. And of course, enterprise architecture. Today, we'll explore how EA teams can leverage the power of artificial intelligence to drive innovation and efficiency in their organizations. But first, let me quickly introduce you to the key players who will be sharing their insights today with us. Joining us from Mega International is our esteemed EA expert, Peter Brunberg, who has been driving growth in the DACH region since 2006. With a robust background in information systems and extensive experience running sales, consulting, pre-sales, and customer success across various IT enterprises, Peter brings a wealth of experience to our discussion today. Welcome, Peter. From our Swiss operations, we have our T2B partner. We welcome CEO Patrick Tütz. Patrick studied economics and computer science, including AI and neural networks. During his career in project and also IT management, he realized the central role of architecture and integration, and thus founded T2B in 2001. Thank you for being here with us today, Patrick.
Good morning, Daniela. Happy to be here.
Lukas Strozzi joined T2B in 2007, and he brought a large experience as an enterprise and application solution architect with him. He specialized in service-oriented architectures, embedded systems, and is also an expert in artificial intelligence and large language models. Thank you for joining us today, Luca.
Good morning, Daniela. Many thanks for joining.
And last but not least, let me introduce you to Colin Wheeler. Colin has spent the last 24 years of his life focusing on helping organizations with enterprise architecture, strategy, and technology, mostly as an independent consultant. For the last decade, his interest has ever increased in neural networks, AI, and LLMs, and he's now on the journey of how to bring real business value from these emerging ecosystems. Hello, Colin. Great to have you today.
Thanks very much, Daniela. Hi to everybody.
Together, our four speakers will provide you with valuable perspectives on how AI can empower EA teams to navigate the complexities of modern business landscapes. Before we start, let me quickly guide you through the agenda. So first of all, we will dive into the intersection of language model systems and EAM with Colin. Next, we'll explore AI and HopeX together with Peter. And following that, we will unveil the AI autonomous platform with Patrick and Luca before finally having a Q&A session. I encourage you all to actively participate by asking questions throughout the webinar. On the bottom right of your screen, you will find a chat section to comment and to talk to all participants. And right next to it, you will have the possibility to ask questions. The questions are only seen by us, and we won't name your name, so don't hesitate to ask everything you have in mind. Without further ado, let's dive into our discussions. Please join me in welcoming our first speaker, Colin Wheeler.
Thanks very much, Daniela. Let me get going over here. So basically what we're going to do over here is we're going to discuss enterprise architecture and LLMs. And what I want to do really is I want to demystify a little bit of things about LLMs in the first place. So let's start off on a little discussion about LLMs. I've got a fair amount of content to cover in 10 minutes, so we'll get moving as quickly as possible. Great. So AIs and LLMs. Over the last few years, as we know, we've seen a lot more accessibility in LLMs, especially from a few years ago when we saw the rise of things like ChatGPT. We want to examine what these frameworks are, what these tools are, and how we can use them in the enterprise architecture space a bit better. I also want to remind everybody, of course, that we're still in the early days of these technologies, and we really need to understand, this is part of a hype cycle. From my own personal perspective, this hype cycle has a long run on it because we don't know what the current limits are of what this technology can provide. And as humans, we always have a problem remembering what 10 years ago was like and trying to predict what 10 years' time is going to be like. So let's dive into some of the history of the timeline over here. And for me, it's pretty important here to remember that, ChatGPT first came out in 2018, not for a massive public release and stuff like that. But that's when the technology started to become really obvious that it was going somewhere. From my point of view, when I first saw it on OpenAI's site. In June 2020, we started to move into the more public release of it, and people started to get to see really how this technology works. And that was a big kick forward. In 2021, we started to see DALL-E and different types of models, text to image models, etc., text to music. By August 2022, they were releasing Stable Diffusion publicly in open source, which was the first really big open source movement in these models. 2023, of course, we saw Stable Diffusion move forward. We saw ChatGPT move forward to GPT-4. Late last year, we saw multimodal models starting to emerge, like blip models from Salesforce, where you can have conversations with images. And we've seen the integration with a lot of commercial tools, especially in the graphics and 3D architecture, 3D modeling spaces. There've been a lot of integrations there. And we start to see, of course, integrations with other tool sets like Copilot, etc. So far, 2024 has been pretty exciting. We've seen Sora, and I hope a lot of you have seen those demos. We've seen Stable Diffusion 3, we've seen the beginning of it. LeChat is a new model that looks to take on ChatGPT's dominance. More and more multimodal models will be coming out this year. And hopefully we'll see a lot more control mechanisms that we'll talk about later, like control nets, laser forms of manipulation of models, etc. So Quick discussion over here about the difference between enterprise architecture models and between these AI models, as we can call them. The enterprise architecture models and the models that you find in Mega, we talk mostly about hierarchical models in enterprise architecture. They're logically structured, they're precise, and they're deterministic. When we talk about these AI models, we need to understand that they're stochastic and statistical models. They're natural language models. They work on neural networks. And it should be clear to us and very important to remember that they are statistical and therefore they need peer review, much more than algorithmic models do from humans and stuff like that. We don't know when they're going to hallucinate. We don't know exactly how they work. So we need to be very careful when we take their answers as the truth. That doesn't mean they can't help us, but we need to be aware of that. Good. Let's talk about a couple of the common AI type of models that we see out there. Of course, first up is the GPTs, the natural language processing models. Also, we know these a lot as text-to-text models. We see tabular models out there now that we've been able to see for a long time, actually. Tabular models that are looking at data that's in spreadsheets or SQL databases and making discovery on patterns, etc. We've seen those sort of things for a couple of decades now. They are getting vastly better. Reinforcement learning, of course, which we've seen in places like game playing and robotics. Graph machine learning, where we use graph models to represent the data. We'll talk a little bit about that later as well as one of the ways of enhancing NLP models. We all know the computer vision models. Most of us have them on our mobile phones and facial recognition, etc. We all see them in our blurred backgrounds today in our video conferences, and a lot of specialized audio models that we've been seeing for a long time, from generation to recognizing patterns to recognizing speech. This has been going on for a long time. It is also advancing at a very, very rapid pace. Okay. Let's talk a little bit about the technology that we're talking about here. And the reason that I dive into this a little bit is there's a lot of myth associated in this area. And it's nice just to give it a base background, and state, look, this is really how these work. This is a sort of life cycle that we see. First is development and training of models. This is typically the, training of LLMs, and it's typically very expensive. It takes a long time. The big LLMs, I saw some calculations that they're costing tens of millions of dollars to develop. Past that, once the model is developed at a base level and they're happy, then they start with evaluation and fine-tuning. This is something that we see that we can start to do in our own enterprises. We can do it in our own environments, and the various different models have different ways that we can tune and train them and benchmark them and get them to perform better. Then we deploy our model into our applications or services. And, there are a lot of tools out there nowadays that allow us to use these things just out of the box. For instance, if you guys want to have a look at them, tools like Olama or LLM Studio allow you to play with these tools on your own machines with very low actual entry-level criteria nowadays. The last bit about LLMs, and this is critical, is continuous monitoring and retraining of data. These things need to be kept up to date. They need to see that biases are not developing, etc., right? And there are a lot of different approaches that we can look to curating and maintaining our models. And this is a space especially where we see a very rapid evolution in the technology space at the moment. Good. Model enhancement beyond training, right, is very important, because when we say, oh, did you train your model on X? This is normally not the case. If we have a GPT that we're using in an application, it's normally the enhancement styles that we talk about here that are the way that we enhance our models to get them moving and going. So fine tuning. We've all heard about prompt engineering, injecting knowledge into our models. We can distill our models or polarize them in certain ways. There are adversarial training methods that we can use to trick and confuse them, to test them. There's transfer learning. There are all these different types of ways of data augmentation, and we'll talk a little bit about these as well going through. Good. I want to talk quickly about the limitations over here, and we need to understand that while these are technological tools, they have a large impact across various different areas as well. And we need to talk and be aware of very much of the social impacts. Here, fact or fiction is an interesting one for me as well, always. We need to fact check everything, whether we get it from a news channel, whether we get it from another human being, whether we get it from a paper, a scientific document. Anything needs to be fact checked. It's the same with these models. There are some difficulties that they don't understand lineage often, right? And therefore, in the functional space as well, we need to understand that lineage is often broken through a number of these different types of models. Technology constraints, mostly in the world at the moment, we still have a world where VRAM, in other words, your GPU's RAM, is the critical playing factor in running these models. So they can be expensive from a hardware point of view still at the moment to run. We're hoping to see a lot of breaks in the future where new hardware, Apple, for instance, is coming out with their M chips. Intel will be focusing on neural processing chips. So there are a lot of developments here that will speed things up and make things better, but they're not here yet. Okay, I want to talk about GPT very quickly before we wrap up. GPT, and this is a beautiful little concept from Luca. GPTs are generational. You know, they don't think, they generate words. So how can we actually get these models to think, right? And one of the ways that we can do this is we force a model to plan. And you can think about this basically as the executive functions in a human brain. The second thing is that we need to remember that these models are pre-trained. They can't learn anything new. They have a trained memory. Retraining them is very expensive. They're implicit versus explicit, so they can't name their sources mostly. And one of the workarounds that we have here that we'll talk about is RAG, Retrieved Augmented Generation. And this also talks about the vector databases, etc., that we talked about earlier. The last thing is that GPTs are transformative, right? So they act on one word at a time, and this can result in hallucinations. And one of the interesting workarounds that you may see in this presentation today will be the solution to create agents where they have a conversation or an internal dialogue, like what happens in our own brains when we talk about things. Good. Finally, what we'll do during this presentation, and sorry, I'm running 2 minutes behind, are there some benefits that we will show you. Firstly, Mega are going to show you some of the beautiful benefits around speed and context that we can get as architects in the EA modeling space. T2B will show us a lot about integration, and their speed and context are massive benefits for architects and for IT departments and for businesses. And lastly, we'll talk about user interaction, which I think is a huge business benefit. So thank you very much for putting up with me, and that's my little piece, and I'll hand back to Daniela quickly.
Thank you so much, Colin. What a great presentation.
Thank you.
Happy to hear all of your insights. And I already see that we have some questions in the question tab. We will come back to that later, so don't worry. This is an opportunity for everyone to engage directly with our speakers so that we can delve deeper into the topics that resonate with you at the end. So don't hesitate to submit your questions in the question tab. Okay, Peter, AI is also playing a significant role at Mega, especially with the recent release of HopeX Aquila, which incorporates, of course, AI support. Could you demonstrate us why this is important and how it enhances our work?
Yes, thanks, Daniela. Thanks, Colin, for this very nice introduction. So I'm very sorry we have to change accent again. I'm from Berlin, Germany, so my accent is more German-driven, with a little bit of French pronunciation because I'm working for Mega as a French company. I will show you, of course, HopeX and AI, but I need a bit of slides before. It's not too much, and I try to stay within my 10 minutes. Starting a bit with, let's say, some enterprise architecture mission. What you can see here on the screen is not what you typically or what many typically expect from enterprise architecture work. this is the more high-level vision. And when you see it, for example, resilience and agility, drive innovation. So these are really high-value tasks. And this is where EA really should be or could be connected to. But at the same time, on the other hand, the reality is often very different. The reality is more low-level or low-value tasks, especially if you start an EA program. Then you mainly have to do with finding the right information, searching for the information, dealing with all the complexity and the incompleteness of data which comes around. Sometimes it even feels like trying to find a needle in a very, very big haystack, and the more data, the bigger the haystack, right? And sometimes you might even feel to be a bit under-equipped. The tool is too simple, it only produces simple results. In one sentence, it could mean you want or need more power for these high-value tasks, but it, of course, still should be easy. So what can AI, especially in HOPEX, do? It can help you to discover data, so help you with the content management to discover data. It can help you to classify data. We call it identification, so to separate business applications, for example, from flat technologies, and also help you to do the mapping between business and IT. And that is what I'm going to show you now. Let me go to HOPEX directly. So that is HOPEX, our start screen. I will focus only on these three elements today concerning AI. There is a little bit more, but let's focus on this because it's a real benefit for you as an enterprise architecture. I go to tools, and the first thing in order to discover, we call it here under application detection, AI-driven APM. What you see here, it is of course already there because it has already discovered all the data. But let me explain you what you really see. On the left hand, you see a list of technologies. This is what the AI system has found in a CMDB, in probably running probably on your servers by agents, whatever the real source of information is. So this is what you initially get and what the AI populates into the repository. That is the first step. Because it has been trained on normalized data, it can provide also the information about vendors. And the second step is in this column in the middle. So the second step was called identification. It means to separate real business applications from just flat technologies. And as you can see here, for example, for the first line, it says application. For the second line, it says application. For IBM security secret server, it says, for example, technology, right? So there is a difference. You see a rating, and this rating is more or less something like a confidence score. So the system is not always 100% sure if it is now really application or a technology. It gives you some justification for you to understand it. But at the end of the day, it's going to be you as the enterprise architect to decide whether it is a technology or an application, right? It's not the system which decides for you. It just recommends and you decide. Dependent on this, on the decision you're going to take, this specific line either flows into the application portfolio, which is this one, and it's ready for further processing, or it goes into the technology portfolio, which is a different portfolio for further processing. Okay. The last step in this smart mapping is our next step in HOPEX. I'm going to my technologies. I go to, two tools. capability smart mapping in this case. And in order to show you what the end result should be, let's say a well-prepared capability map with all the capabilities, business capabilities here in place, and all the applications connected to the capabilities, some indicators applied to it, and so on. This is what brief, but it all starts, of course, with the right mapping. And again, AI can help you. You have to select simply a portfolio, which is a subset of applications, and I'm going to select global bank applications for it. I have to select a capability map. I have several capability maps in my demo system. I'm going to select the mega bank capability map for it. And this is what you get out of it. There is already a first mapping, but I want to see it on a capability map. I make it larger. And what you see here is all the capabilities you've seen already in my screenshot before. But in this case, for a bank, it's a reference capability map. And what you can display now in green are all the applications which are automatically suggested for mapping, right? It has not been done yet because, again, the decision is yours. It's a suggestion by the system. But for example, the AI suggests to map the core bank system to several capabilities, like checking accounts management, collections and recovery, etc., etc. It means the first step is quite easy and quite fast, okay? It has not been executed yet. That is, again, your decision, you update, and then it's done, and your capability map is ready for further processing, okay? That means at the end of the day, you, of course, gain quite a lot of time, especially during the initial data collection phase, but also later. The other thing is, decision is yours. It's not the system who's going to decide for you. It's your decision, right? The system just supports you. And sometimes it might be even interesting to see what the AI suggests compared to what you probably initially expected. Maybe you wanted to do a specific mapping and the AI suggests something different. So let it surprise you. Maybe it's even better than your own thinking, this specific case.
I think we lost Peter there for a moment. Let's see if he's coming back.
Okay, it seems I was a bit disconnected, but...
Yeah, perfect, you're back.
Okay.
Just go on.
This was the end of my part of the story, and I'm handing over now to Patrick and Luca.
Thank you, Peter, for the presentation. So it seems AI is well implemented in several areas of HopeX, really benefiting for HopeX users. But we're taking it obviously even further. Non-HopeX users are also benefiting, and Patrick and Luca will demonstrate now. So great, Patrick and Luca, the stage is yours.
Thank you very much, Daniela. So we talked a bit about history, and you mentioned I was studying in early times already on AI. In the late 80s, we didn't really make it work. What we made work at the time was expert systems. So expert systems were very specialized things where we did basically extract with business analyzers rules from the experts and put that into systems. So it was a very narrow scope that we could do. In the late 90s, then we actually did search and ontologies and knowledge management. So still people, classifying information. We asked everyone to tag information to really find it again. And of course, we were working on this knowledge still, but the scope was already a bit broader. So we did it, for example, with pharma companies, others did it with banks. So we had this kind of knowledge management. And then we extended that a bit with graph technology. We added that into the, let's say, technology capability to manage knowledge. And that was in 2015, really, where we started doing that with T2B. and our customers, but still the focus was on a domain. You know, it was pharma, clinical development, or it was some government-specific task. But then when ChatGPT came out, I was surprised as everyone else. So it was really interesting to see all this. And of course, it would be now interesting to see, you know, how this is really extending all that scope to basically all knowledge. Yeah, so we thought about, what would that do for enterprise architecture? And we have seen, of course, the AI supporting the enterprise architect. With Peter's demo, we've seen could have a feeder, classifier. We could also add more features, and I think there's somewhere things on the roadmap of all providers that you could actually make verifications, make support to editors to easily edit other things, and of course also to support repository users who are maybe not experts in the tool, like you have a really natural language interface to ask for reports. So I think that will be features that will be coming soon. We as integration experts, of course, thought about, how could we use or the AI use the repository. So the data that is in there is, of course, very interesting and can be used by other, let's say, for other purposes. Yeah, so we have seen this document-based LLMs initially. Then they started to integrate that, and of course, this integration evolution then continued. The LLMs, let's say general purpose LLMs, could now call APIs external, so extend their reach from the initial documents that they were trained to. And then about last year, the first time these autonomous agents were popping up. And in our demo, you will see a little bit of that. So this is really about agents communicating to each other, and some of the providers, of course, then provide platforms to do that. And I think the end goal would be an autonomous platform, and that's what we are shooting at with our Talabus. So this is coming, of course, from Thalamus, connecting the two brains, and this is connecting the AI to our brain. So Talabus demo that we will see will cover these two areas. The point E, we did not yet really finish, or we are still working on it. What we'll see is how to call simple APIs or APIs in general, and how these autonomous agents are interacting with each other and producing results by themselves. The demo will be on basically a chatbot answering questions about open bills for specific customers and what needs to be done to achieve that with AI. So Luca will show you this demonstration, and I hand over to Luca.
Thank you very much, Patrick. I will now share my screen. Just a second. And there we go. So thanks very much. My name is Luca, and I'm working at the Talabus platform. As Patrick has said, I will present a simple example where we can chat with a customer application and a billing application. So let's say that in our organization, there is a customer and a billing application. They provide one interface, one application program interface. And our colleagues, the architects, using Mega, they have created a detailed model with detailed design specifications of the customer, billing application, and of their interface. The requirement is that we want to have a chatbot to allow users to get and perhaps also modify information that is in the customer or respectively in the billing application. There could be internal users like call center agents or the final end customer. Of course, we need to consider appropriate security, authorization, authentication issues, but for this simple demonstration, we will limit ourselves to only read information, and we will not focus on security aspects. The first idea to add a chatbot would be to add it to the customer application. So we build a chatbot directly inside the customer application. The problem in that case would be that it cannot natively access the billing application information. So the industry normal solution to this is to build a chatbot outside, or to procure by purchasing license for a platform that has an integrated chatbot. And we are developing in T2B the Talabus platform. It has an integrated chatbot. And this platform can autonomously learn to connect to other systems or other applications. So that would be our goal. And I'll give you a summary of the rest of the presentation. We wanted to have Talabus learn to connect to customer and billing application through the application program interface. We do not know the application program interface specification, so the first thing to do is to teach Talabus to connect to the mega system to fetch detailed design information about our real-world systems, and after then to connect to them. In order to do this, we use the Talabus feature called Skill Teacher Team. This is a team of artificial intelligent agents that together collaborate in a way that I will demonstrate soon in order to produce the results. The results are requested by a human that sets the goal of the team. This human in these slides will be called the teacher. So the teacher gives the first goal to the skill teacher team of agents, and that is please connect to Mega and fetch information about the detailed specifications of the interfaces that are available by our customer and billing application systems. Once this information is available, the teacher will set another goal, that is, please develop the skills, as we call them in the Talabus platform, develop two new skills. One is to access customer information, and the other is to access billing related information. This is a one-time effort only. Once these skills are learned, they are available to all authorized users of the chatbot. As I said in this presentation, we don't focus on the details about who is authorized and who is not authorized, so let's just skip this section and say, so the goal is that users can use the Talabus chatbot to access information that is stored in other systems such as Mega or customer or billing. So how does that work? Let's start from the skill teacher team. Let me introduce you. The skill teacher team is composed of several agents here. We have shown the most important four ones. There is a large language model which has been specially trained to produce code, so it's developer. There is a model that has been instructed to perform code reviews. What are code reviews? Well, this agent must spot obvious logical mistakes before we proceed further, has to spot violations of security principle and security guidelines that are mandated by our organization. It must spot violations to the coding guidelines of our organizations, and so on. Teachers can set their specific guidelines that the reviewer will ensure that happen. The tester is obviously going to test if the programs developed by the coder and reviewed by the reviewer are working or not. If they are not working, we'll give feedback. And last but not least, there has to be some accounting, some source revision control to be executed. And this is done by one agent, which we call the clerk. So the human is important, of course, very important. The human sets the goals. So we have this person in the role of a teacher, and he sets the first goal. He or she sets this goal. That is, write a program that will query the Mega application program interface, which is located at this physical address, and using it, retrieve all applications that have at least one interface, which is customer and billing applications. So the skill teacher team gets this goal, final goal, and starts. The coder starts to do his job. They will work in a cycle. So each hands over its draft results to the next one and will receive eventually feedback in case that something has to be reworked. The first to start is the coder. And the coder doesn't start immediately to produce the program. It will first make a plan that it will follow later to produce the various parts of the code. Planning is an important step, as Colleen has said. It resolves the problem that large language models do not have the capability to think, but they have only the possibility to emit words one after the other. But a trick to force them to think, the solution is we force them first to produce a plan in words by outputting words one after the other, and then they have to follow the plan and produce the actual result, which is the code in this case. So the coder has produced the first version of the source code of the adapter for the Mega APIs, and the next step is taken by the reviewer. Here in the screenshot, we have only taken recommendation number 6 from the reviewer, and so the reviewer has checked the security guidelines, coding guidelines, logical errors, and other information, and has given 6 recommendations. It has already eventually, when we reach this screenshot, gone through 1 or 2 review cycles, and the coder has corrected the source code based on the recommendation of the reviewer. The reviewer is responsible to give a go or no-go decision, whether to start testing or not. And in this screenshot, we show that the reviewer says, okay, let's proceed to testing because the first round of improvements in the code has already happened. And the tester starts for the first time to test the actual source code. In this screenshot, we see that there is a bug. The program doesn't work. So the tester will reject the produced latest version of the source code back to the coder and will give indications of what are the problems and what are recommended solutions. There will be therefore another cycle. The coder will fix those errors. The reviewer will approve or reject the changes. If they are approved, the tester will test again. After various cycles are concluded, the result is that the Talabus platform has learned to connect to Mega and fetch information. The result, we call it in the Talabus platform a skill. So we say in human terms, Talabus has learned a new skill. And now the human user uses this skill by chatting with Talabus. And the chat, I will zoom in the picture. The chat consists of a question from the user, please connect to Mega and fetch information about applications and interfaces, and include all the necessary information for the next steps, which is the endpoints. The Talabot, which also consists of a team of multiple agents, confabulates, gets information, tags information, and gives the result to the user. So yes, there are twin applications, customer management application and billing management application. They respectively have an interface, and this is the first endpoint, that is the second. So now, which is reflected in the real world as this picture. So now the last part is that the human again sets a goal for Talabus. This time, the skill teacher team has to write 2 additional programs using the information coming from Mega, connect to customer and connect to the billing application. Again, there would be a cycle of those artificial intelligent agents, which we do not show because it's the same as before, and it will produce 2 programs. That is, we call the skills. So Talabus has learned 2 more skills, fetch customer information and get billing information. Both of the names and the descriptions have been determined by the artificial agents, the clerk in particular. So now we have our users, internal call agents or external customers that under the prescribed security guidelines can chat with Talabus. And with Talabus, they can ask questions like, give me please information about a customer named John or a customer ID 12345. And Talabus will use the adapter to customer application or to the billing application or to both to deliver the requested information. or if a change, like a change of an address was requested, to change the appropriate information. So the information in this case is example street 123 in Bern, Switzerland. This is the phone number, that is the email, and that is the customer ID of John. And next question is, does John have any outstanding bills? And says no. He paid one bill of 100 on the 15th of May, but there's another bill due on, the one of May has not yet been paid, and the one on 15th of February has already been paid. So what is the summary and conclusion of these slides? So first of all, Talabus can be directed to learn how to connect to Mega to fetch information about our organization's enterprise assets and systems and interfaces. The second is using this information provided by Mega or directed by the user with additional information coming from other sources like interface specifications, Talabus can learn autonomously to connect to any other application that provides an interface. And how long did it take T2B to create this presentation, to create the skills that we have screenshot and provided in the presentation? It took 5 minutes for each of the adapters. So the skilled teacher team is incredibly fast and precise. This was very simple cases, 5 minutes were enough. On simple average cases, it's 5 to 10 minutes. For moderately complex cases, it can come up to 1 hour. And now for me, the last but very important question or topic would be, is the human completely excluded and overruled by the machines, like the Terminators that take over humanity? We don't think so. We think that the hybrid teams with a mix of human and artificial intelligence agents delivers the best and is the most efficient. That is because each member of the team in different roles brings their best practices, their best qualities. Humans direct, humans have goals, humans take decisions. A human make a phone call to a colleague to request information that is not available in the organization. The machines cannot do that. The machines should not take important decisions. The machines can do other stuff, low-level coding, code review, or produce and review and test continuously code and deliver the results. A hybrid team is very, very efficient and produces good results. In Talabus, we are developing both completely autonomous teams and hybrid teams, and users can just choose for every specific use case at any time to have a completely autonomous built solution or a hybrid solution. So that would be my last slide. Daniela, your word. Thank you very much.
Great. So I will just share my presentation again. Great. Okay. So thank you, Patrick and Luca, for the presentation. It was great. And before we conclude today's session, let's take some time for your questions and your comments. I encourage again everyone to share your thoughts in the chat or your questions in the section right to the left. As I reviewed your questions during the webinar, I noticed that 3 of them consistently resurfaced. So I've tried to resume your thoughts and listed them here. So let's begin with the first one. LLMs are inefficient from an energy point of view. Training models cost a lot of power, and even compared to other types of queries, they are inefficient. How can we deal with this issue? Maybe, Colin, you would like to answer that first question?
Thanks very much, Daniela. And what I'm going to do is take the advantage to actually wrap a question from one of our participants into that as well. Yes, they do take a lot of power, to initially start generating them, and they are inefficient. That is the truth. However, the speed that they can achieve over what we can do as humans and individuals is significant, and it is there and clear. What we should not do, as usual with any of these things, is become too reliant on the way that they work, right? We need to constantly start refining. And this segues into one of the questions that we received, which is, these LLMs are very resource intensive. Should we not be using smaller language models more commonly, to deal with things? And the answer is yes. I mean, we have seen in the past, we saw a lot of small language models being used in chatbots and various other things. And what we noticed there, or I noticed in a lot of enterprises, was they need a lot of curation. The data set is constantly changing. They change, so they need curation. And this is the same issue that we have now, but we see a lot of more specialized models developing out of the large language models. The space around Llama, for instance, is very interesting to watch. The new Llama models are underneath 4 gigabytes of VRAM requirements. We will see these models get smaller and more specific. And they do get more focused and more accurate as this happens. So yes, we need to refine these things to make them more efficient. And we shouldn't become dependent from either individual or from an enterprise level on the large oversized models, right? We need to learn to work better and refine them. And this is part of what Luca and T2B brought up very nicely, which is this is part of a conversation with these models. And that is what's so critical for the proper curation of these tools, in our enterprises and our societies, to start the conversation with them correctly and refine them to the point of where they are more useful and more efficient. Thank you.
Great, thank you, Colin. I believe we have a second question for Peter. So AI-based automation on functional level is great, but does HOPEX also support users in a more practical way? Peter.
Yes, Daniela, thanks a lot. So what I've shown in HOPEX earlier is, it has been more on a functional level, right? But of course, on a day-to-day basis, users want to be supported as well. And we provide, for example, very good chatbot, which has been trained on mega documentation, which means you can easily ask it for advice. You can say, for example, how can I create, I don't know, a diagram? How can I map applications to technologies, etc., etc.? And it will give you the advice, always pointing you as well to the right page, for example, in documentation. And what it also can do, you can provide a verbal description of a process, for example, and it generates for you a BPMN compliant diagram, which is already very nice. And then you can later go into this diagram and make it probably more complete or more nice, right? So there is a lot of guidance for users around doing their daily work.
Okay, great. Thank you, Peter. And the last question was, I think, more for Luca and Patrick. So will every user be able to ask the AI about any real data? So for example, if somebody in another department can ask the AI about invoicing information for a customer, just because the AI has extracted interface information from the EA tool.
Yeah, basically our Talabots is a platform. So we are connecting things into it. And one of the things we connect is a large language model, or rather a small language model, which is just specific for interaction with the system. And then, let's say, the customer specific parts, they are used and stored in specific areas. So I think Colin had mentioned it, we use vector databases or graph databases to actually store specific data for AIs. And on the other hand, this security question is a typical integration question. This is really making sure that a person is accessing a system only with his own privileges. This is not yet implemented, I have to say. We are working on that. So the Talabus is a new platform we are working on. It's work in progress. But that's an easy thing to do. So that one we know how to handle. Other things like Bernard's question, how to integrate change into the whole thing. So let's say if the billing system is replaced by something else, then of course the system would have to learn it again. Again, an integration question, basically mega change, replacement of a system by 1st of January 2025 will trigger a flow that will then teach the teacher team to actually go again and recreate the skill. It might also be the other way around. We didn't yet try that one. That actually the AI failing to connect to the old system will see what do we have to do. Do I have to relearn it? That's something we didn't yet test, but it's an interesting idea to do that. We'll do that.
Great, thank you, Patrick. I've just checked out in the question tab. We have a lot of questions. I believe we cannot answer every question for today, but we will coming back to you via email. Maybe let's take another question. A prerequisite for this use case is to have API-enabled business applications. Would it be possible to connect at the database level to search for answers, perhaps also using the metadata from the Mega repository? Maybe Luca, you will have an idea.
Yes, thank you. Of course, it is possible. Yes. In principle, Talabus and other platforms can write programs, and programs can do everything. The challenge here, a particular challenge, is when we want to access the database level of another application, we should know the data model. We should know the business case. We should know where is data stored at some level, at the logical level or at the database level. In other terms, we need think if we would do it as a human. As a human, I would like to receive a documentation of that database first. Then I would like to read this documentation, and after that, I would like to test what is possible to do and what not. That's the same for a team of machine agents. Read documentation first. If the documentation is not available, then there will be experiments to be made. And that requires far more intelligence than is currently implemented in the Talabus platform, but we are working at enhancing the intelligence. Thanks.
Or one
Thanks,
to integrate a specific component for that. There is already database query agents. So maybe that would just another component we would add to the Talabus platform.
Thanks, Luca and Patrick. I just want to add over there that this is the criticality of why we talk about this AI benefit to architecture, right? This is where we mature our data architectures, our application architectures, our process architectures all together so that the AI can use all of these things as inputs, right? If it can read your data modeling tool, it can start to understand what the shape of those databases is. If it understands your process landscape, it can understand how that data changes through different systems and integration. So it's critical for us to get all of our architecture maturing at the same time.
Okay, great. So I think let's take a last question as it is 57. Let's take this one. In my experience, many CMDBs have poor data quality, especially above the infrastructure. Has HopeX been trained to help make sense of bad data, or does it rely on good data quality? Peter, maybe you
yes,
would like
it has
to
been
answer
trained,
that?
of course, and of course it can deal with poorer data quality. There is a normalization feature provided, which helps to normalize and get as a result a good data quality. So the answer is yes.
Okay, great. Then I would say we're almost at the end of this webinar. So thank you so much, Patrick, Luca, Peter, and Colin, and the audience for all your great questions. We noted down everything, and we will be coming back to you via email. So don't worry. So as we approach the end, I want to express my gratitude to each of you for joining us today. I hope you found our exploration of AI and EA inspiring and also informative. So special thanks to Patrick, Luca, Colin, and Peter again for sharing the expertise with us. But remember, the conversation doesn't end here. Stay connected with our speakers on LinkedIn and also on our different platforms. Colin, for example, is very happy to offer some free coffee calls via Teams to discuss perspectives on AI and EA on any of your current challenges. But also feel free to contact Peter, Luca, and Patrick on LinkedIn or by email. You can also discover, for example, our latest updates on our website, read content pieces and trendy topics on our blog, and you can also find our on-demand webinars on Brighter. Let me send you quickly some examples in the chat for everyone. I also put a German blog there as we have a great DACH audience today. Yeah, so don't hesitate to contact also me if you want to speak to an expert, and I'll redirect you. Thank you all once again for being part of this journey today. Have a great day and see you soon.
Thank you to you, Daniela. It was a pleasure.
Thank you.
Very well done. Thanks, Daniela.
Thank you. Bye.
Bye.
Thank you to everyone.